Benford's law. Fake numbers in tax returns, invoices, or expense accounts claims often display patterns that aren't present in legitimate records. Some patterns are obvious and easily avoided by a clever crook. Others are more subtle. It is a striking fact that the first digits of numbers in legitimate records often follow a model known as Benford's law. Called the first digit of a random chosen record X for short, Benford's law gives this probability model for X. Note that a first digit can't be 0. So here, the probability of the first digit being 1 is about 30%. The probability of the first digit being 2 is about 17%, and so on, right? So this is Benford's law. It should follow something like this. A forensic accountant who is familiar with Benford's law inspects a random sample of 250 invoices from a company that is accused of committing fraud. The table below displays the sample data. So out of the 250 invoices, 61 of them had a first digit starting with 1, and so on, right? Are these data inconsistent with Benford's law? Carry out an appropriate test at the alpha equals 0.05 level to support your answer. If you find a significant result, perform a follow-up analysis. Describe a type 1 error and a type 2 error in this setting and give a possible consequence of each. What do you think is more serious? So we want to perform a test at the alpha equals 0.05 significance level of, so our null hypothesis is going to be that, yes, it does follow Benford's law, right? That the proportion in our samples follow Benford's law, right? So P1 is obviously going to represent the proportion, this proportion, right? The first digit being 1, so that is about 30%, right? Versus at least one of the P sub i's is incorrect, right? Okay. So we should use a chi-square goodness of fit test if the conditions are satisfied. A random sample was used. A large sample size, so the expected counts in each category are, so first digit, so out of 250, you multiply it by the proportion it should be, and there should be around 75.25 first digits in our sample, which, as you can see, that's a huge discrepancy already, right? The second digit is 250 times 0.176, which is 44. Yeah, it's a pretty big discrepancy, right? And so on, right? First digit is 3, 250 times 0.125 is 31.25. 250 times 0.097 is 24.25 for the first digit being 4. I believe that's a huge discrepancy too. The first digit being 4 is, so that's 0.34, and the expected is 24.25. So that's a discrepancy of almost 10 counts, right? The first digit being 19.75, and so on, right? So the independent condition, or the 10% condition, so 250 is less than or equal to 1/10 of n, where n is equal to the number of invoices at the company. So I think that's safe to say that that does satisfy. So all the conditions are met. So let's go ahead and do chi-squared statistic. So chi-squared, so the way you do chi-squared is you do the actual that we got from our sample, you minus the expected, which is these numbers that we got here, right? So the actual number from the sample is 61. You subtract the expected amount, right? And then you square it, and then you put over the expected amount, and you do it for each one of these, right? Okay, so if you do this calculation, you get equals 21.563, and the degrees of freedom is 9 minus 1, which is 8. So what we do is we go to our table, and here we go, degrees of freedom 8, and it's 21, what was it again? 21.563, so 21.563, that would be right in between 0.005 and 0.01. So we know the p-value is between 0.005 and 0.01. Let's go ahead and do that. 0.005, p-value 0.01. So the p-value is definitely less than alpha, which is 0.05. So we reject H naught. We reject the notion that this sample follows Benford's law, right? So we conclude that the invoices are inconsistent with Benford's law. Remember, the breakdown of the chi-square statistic was what we had up here, right? Up here, but let's go ahead and put the numbers to see how big of a discrepancy everything is, right? So chi-squared was equal to 2.699 plus 0.818 plus 4.418 plus 3.920 plus 1.396 plus 0.036 plus 3.879 plus 1.770 and then plus 2.630. So these associate with these numbers here. So those are those numbers carried out. And as you can see, the big discrepancy is 1, right? The first digit being 1. There's a huge discrepancy there. 3 is another one, right? The first digit being 3. That's another big discrepancy. The 43 minus that, over that, right? It gives us that big 4.418. And then the fourth digit is another one. This difference here is going to give us that 3.920. So from this, we can see that the largest contributors of the statistic are amounts with first digits 3, 4, and then I also saw 7, right? So you can see that 3.879. Those are big contributors, right? There are too many amounts that start with 3, 4, and not enough that start with 7. So with the 7 one, let's go ahead and go up here. So the 7th, you can see that the expected is 14.5, but what we got was 7. So there weren't enough that started with 7, right? Because there were seven digits. Or there were 7 of these invoices that started with the first digit being 7, right? So we can see that there were not enough that start with 7. Similarly, there are too few that start with 1 or with 9, right? See, with 1, it was 61 minus 75.25. The expected amount was 75.25, but we only got 61. So there was a lot of discrepancies, and it definitely was not following Benford's law. So a type 1 error is when we reject H naught when H naught is actually true. A type 1 error would say that the company's invoices did not follow Benford's law, suggesting fraud when in fact they were consistent with Benford's law. A type 2 error is when we fail to reject H naught when H naught is false. A type 2 error would be to say that the invoices were consistent with Benford's law when in fact they were not, right? And of course, a type 1 error would be more serious here, alleging that the company had committed fraud when it had not, right? So saying that their null hypothesis, that we should reject the null hypothesis when the null hypothesis was actually true. In this case, the null hypothesis was that this company was following Benford's law. And rejecting that would mean, like we concluded in this one, that there was fraud at their company, right? Which we did conclude in this assessment here.